All right, welcome. I'm not here obviously again. I really do expect you to be able to learn from these videos because it's just the same lecture I would give you. I'm just not standing in front of you. So this will tell you sort of the plan for today. Today we're going to wrap up acids and bases, which is section 4.3. Oh, I already screwed up. Okay, fine. Section 4.3. Hopefully you've read this by now. If you've read it, then hopefully what we do today, where we talk about gas-forming reactions and neutralization reactions, are very difficult. If you have not read section 4.3 yet, please get after that. You really need to have a very thorough understanding of section 4.3. All right, so you can see right here in bright, bold red, turn in the reading assignment from last week. That was the one that was not published. It is now published on Canvas. You can submit that by just taking a picture of your notes if you hand wrote it, or you can type them in. But turn that in. I've had only like 6 or 7 people turn that in so far. But let's get that in. And then also your net ionics are due today. Well, they were due yesterday. If you haven't turned those in, turn them in as well. All right. So the plan, we're going to cover acids and bases. We'll talk about the practice problems that will then turn into this homework assignment. All right. Tonight, please read 4.4 on oxidation and reduction. You'll be learning about that tomorrow. And it would be a lot better off if you read in advance. Okay, the objective is to be able to write and balance net ionics for acids and base reactions. So let's get after this. We already talked about acids and bases a touch, but make sure, that didn't work, whatever. Make sure that you know this. In an acid-base reaction, the acid, which is a proton donor, it donates the proton to the base, which is the proton acceptor. So you can just see this picture real quick. We're not going to stress a ton about that yet, but we have a whole different chapter on this. But the proton goes from water to NH3. If the proton leaves, it leaves just OH, and now you have NH4+. All right, so this would be my acid, this would be my base, and this would be my conjugate acid and conjugate base, which we'll learn about later. Don't worry about that. But just know the H is moving places. All right, generally, when solutions of an acid and base are combined, the products are a salt and water. And if this was a strong acid and base reaction, it always produces the same net ionic equation, which we'll talk about on the next slide. It isn't always strong, though, so we got to make sure that we remember the acids and bases that are strong versus weak. So, when a strong acid reacts with a strong base, the net ionic equation is as follows. So, a strong acid, strong base, makes the salt and water. And notice, this is aqueous, that's aqueous, and this is liquid. When we break this apart to what we call the complete ionic equation, where everything's broken into its parts, how it really is, the complete ionic has all of this stuff, all right, forming this. All right, if we look through, we eliminate everything on the same side of the arrow. And this is unfortunate how this is typed. Well, let me just fix it. All right, turns out that was a lot harder than I planned, so I just kind of left it because I didn't want to change everything. But just realize that the right side of this is actually down here. So I'm going to eliminate everything that's on both sides of the arrow, or in this one, what's on top and bottom. You have Na plus right here. You have Cl minus up here and here. But you don't have H plus in the top and the bottom. It's only in the top. And same with OH. So you end up, I don't know what this slash is, ignore that. You end up with H plus being left over, OH that is left over, and just water as a liquid. So if you have a strong acid, strong base, the net ionic is always H plus OH minus goes to HOH. Now you'll see that as H2O as well. They are both the same thing. You can write them either way and that would be acceptable. Okay, that is if we have a strong acid and a strong base. But we don't always have that exact situation. Okay, sometimes we have what we call a weak acid and a base. And we're not necessarily going to have to worry about this too much until we get into later chapters, like specifically chapter 15, 16, and 17. But if you have a weak base or acid, we'll just do a quick one right here, like vinegar. That's acetic acid, which is HC2H3O2. And since it's weak, we put an L right there. Plus a base, we'll say it's a strong one, like NaOH again. All right, it reacts to form NaC2H3O2, and that's aqueous. And we're left with the H plus bonding with the OH minus, so that makes water. Okay, this was aqueous as well. So then we would write the complete net ionic with anything aqueous. So this is still, since it's just a liquid, because it's weak, meaning it doesn't dissociate, we have HC2H3O2 liquid plus Na plus OH minus. Those are both aqueous. You don't need that, but just showing you this. All right. Goes to, this is aqueous here, so Na plus C2H3O2 minus plus HOH liquid. Now, if we were to eliminate things, the things we would eliminate would be the things that are the exact same on both sides, which would only be Na plus. It is Na plus on the left and Na plus on the right. Now, this is an ion. The acetate ion is here, but it's not an ion over here. And same with hydroxide. It is an ion here, but not here. So the overall would be HC2H3O2 liquid, because it's weak, plus OH minus goes to some acetate ion plus HOH. These are the things that actually underwent a change. Na did not. It was a spectator. It just saw all of this happen, but had nothing to actually do with the reaction. Okay, so if it's weak, they get much more complicated because the acid is present as a liquid, and then we still form water, but we have the anion of the acid, and we have hydroxide. If it's a base, it's exactly the same, except for you just switch the things that stay liquid and are ions. Okay, now let's get into what really gets complicated. All right, and that's if there is a gas involved. I should also, I guess, before I get there, sorry, we should also check to see if there's a solid involved in these reactions. And I'm going to talk about these as red flags. Because net ionic equations, they're pretty easy until we throw in some things that don't behave how we expect them to. And I'm going to call those red flags. So I just did weak. Let's do solid before we move on to if there's a gas involved. Solid is actually very similar to exactly what we just did. So we would have, let's say, all right, had to get a drink there. Let's say this time I put solid sodium hydroxide. So if it's solid, I need to put an S instead of an AQ, and I add hydrochloric acid that's aqueous. We already know from the previous one, this makes NaCl aqueous and water liquid. All right, if I break this down into the complete ionic, which I didn't cover in class a ton, but you should have read it, the solid is still represented as a solid. Anything aqueous is broken into its parts. H plus Cl minus goes to another aqueous thing here, which is Na plus Cl minus. And that goes to HOH, which stays together because it's liquid. Then, canceling out anything that was repeated, on both sides exactly the same, you'll see that this time it's only the chloride ion, because the sodium was a solid over here. So if there's a solid, we have the NaOH, solid, plus an ion goes to ion, plus, oh, this was supposed to be a plus sign right here, plus HOH, liquid. Okay, so if there's a solid, you have to account for the solid, and then you have to account for the one spectator ion. Okay, so that is another thing we should pay attention to when we do these net ionics. All right, so the red flags that we should be aware about. When we read the problem, if it says the word solid, life's going to be tricky. If it gives us an acid or base that's weak, life's going to be tricky. Or, this is the hardest one for most kids, and that is if there is a gas involved. Then it gets tricky as well. So we'll spend a while on that now. All right, so this is in the book. If you want, you can have Heather pause this and you can take a picture of it. Tons of these numbers should be subscripts, so it might look a little bit odd, but just, you'll figure it out. So here we go. Gas-forming reactions. In these metathesis, and metathesis just means everything switched places. I've been calling them double replacement. All right, or it's what we've been balancing this whole time, a precipitate reaction. These metathesis reactions do not give the product that we would expect. The expected product decomposes to give a gaseous product of CO2 or SO2. All right, then this really should have said, and this one, H2S, gas. So those are the three gases that are produced when we add acids to these things that have these ions. All right, so these are really important red flags. If you come across any of these when you go to balance and do a net ionic, you have to be careful. Okay? They are the carbonate ion. If you see something with the carbonate ion that reacts with an acid, it's going to produce water and carbon dioxide. If you see the hydrogen carbonate ion, it's going to also be like the carbonate ion and decompose and form CO2 and water. SO3, all right, that is similar. It breaks apart, and it doesn't form carbon dioxide this time because there's no carbon. It forms sulfur dioxide and water. Okay, so that's the sulfite ion. So you need to know their formulas and their names because it could come in both ways. So I'll write that up here. This one's hydrogen carbonate. That was hard to write that small. And then this one's just carbonate. And my slate just really failed on that one. Let me try that again. All right. And then coming down here, the other ion is just the S-2 ion or the sulfide ion. These are the red flags that you need to be aware of. They do not behave how you would expect them to. You would expect, just to rewrite this one, you would expect calcium carbonate, let me get this as small as I can, and HCl to just break apart into H2CO3 plus CaCl2. All right, that is when we just break it apart and we swap places. And that's what we've been doing, and it's been working fine. But now, this thing, carbonic acid, in these reactions, does not behave how we would expect it. It's not stable, so itself breaks into two parts, H2O, liquid, and carbon dioxide, gas. This would be AQ, as you can see up here. This would be solid. That's another red flag that we talked about just a second ago, and this would be AQ. So there's all sorts of stuff going on in this problem. You would notice the only thing that is aqueous in both is the chloride ion. Okay, I could write it out, but that's all. So your net ionic, you'd have CaCO3 solid plus this H minus goes to H2CO3 plus Ca plus 2. All right, so these are tricky. They're also extremely important, as you can see right here. The people that write the AP test, they love to try and get you to get a problem wrong. It's not very nice of them, but oh well. It's the world we live in. Okay, they love, when you do your net ionics, they love to have one that produces a gas, because it just is one step harder than just a normal net ionic. So here I have our just three main red flags. We have our carbonate and our hydrogen carbonate. When we see that, we know it's going to break down into water and carbon dioxide. When we have H2S gas, we know it will decompose into, when we have the sulfide, like Na, oh, that's black. Like if we have Na2S, the sulfide ion breaks apart. This Si2, it reacts with hydrogen to form hydrogen sulfide gas. And then we have our SO3, our sulfite. It decomposes, that's a T. It decomposes into water and sulfur dioxide gas. Put the names up here. Okay, if you didn't write the ones down before, please write the ones that are here. Carbonate breaks down to water and carbon dioxide. Hydrogen carbonate breaks down to water and carbon dioxide. Sulfide, the S-2 ion, it reacts to form hydrogen sulfide gas. All right, and then sulfite breaks apart to form water and SO2, or sulfur dioxide. So I'll wait just a minute there if anyone needs to write those down. Those are our red flags. They will give us trouble if we don't pay attention. If you need more time, have Heather go ahead and pause it. All right, so let's do a practice problem together. So we have Na2S plus HCl. So we would check our red flags right here. And I don't know if you'll see that well in the video, but hopefully you have this in your notes. So I don't need to worry about the acid. I'm worried about this solid. And I'm wondering if this sulfide is one of my red flags. And I would just check down here, and it's right here. Sulfide, oh sorry, I'm an idiot. It's right here. Sulfide is right here. So it is one of my red flags, and it produces H2S. Now this one isn't that bad because you expect it. You just need to know that it ends as a gas. So we have Na, and it grabs Cl. And we know that's aqueous. And then the other two things left are hydrogen and S. This is a -2, this is a +1, so it's H2S. Now, this is what we would expect if we swap partners. You just need to make sure you realize that is a gas at room temperature. So now, the next thing, I'm going to write the net ionic, I'm going to write the complete ionic, and then the net ionic after that. So this is a solid, so I'll maintain that. This is aqueous, so I write it in ion form. And it goes to Na plus Cl minus, because that's aqueous, plus I have H2S gas. Now, all day I have not been balancing them very well. So I better make sure that you guys know there's a 2 in front of here, there needs to be a 2 in front of there, and a 1 and a 1. That does matter because we do need to make sure we have this all balanced. So I'm going to put a 2 here, a 2 here, a 2 here, a 2 here. And then I'm going to look at what I can eliminate. The only thing I see that's exactly the same on both sides is the Cl minus. All right? Na is a solid here, or stuck in a solid here. Na is in an ion here, so it underwent a change. So we just can eliminate this. And then I'm going to rewrite. Na2 solid, that's an S, sorry. That's just ugly. we go, plus 2H plus goes to 2Na plus H2S gas. All right, then you should double check that it's balanced. 2NAs, 2NAs, 2H's, 2H's. And this would be the net ionic equation for this gas-forming acid-base reaction. Okay, now let's have you do this problem. So is there a red flag? You bet there is. I'm going to have Heather pause this and see if you can work through this problem, and then we'll go over it together. All right, so let's go ahead and talk through this one. I'll just move this down, and I already have it all done. So we had the solid, so we had to make sure we represented that. In the complete, we had aqueous NaCl again, and then since it's carbonate, it decomposes to liquid water and carbon dioxide gas. When I wrote the complete ionic, I wrote these as in their separated form and rewrote the whole problem. Then just like one we've already done, or two we've already done today, once we did all that, the only thing that was the exact same on both sides was the chloride ion. So we eliminated that. And then I rewrote the net ionic equation, which was Na2CO3 solid plus the hydronium ion goes to Na plus H2O plus CO2 gas. And I never balanced this, so I dang well better if I'm going to be a self-respecting teacher. All right, there's two H's, so there's a 2 here. There's two NA's, so there's a 2 there. You need it in your net. I should have done it up here, but when you get to your net ionic, you'll be able to see that you had issues and you can fix it there either. Okay, let's do one more together. So I'll have this pause this. All right. I think we already did this one. I didn't really think this through, but you can just check real quick to see if you did it right. I'm pretty sure we already did this same one. All right, so hopefully this was an okay thing. Make sure you have your red flags in your notes and make sure that you start committing those to memory. This is not something you'll be given on the AP test. It's something you'll be expected to know. Okay, so what we've learned this week or over the last little part here, all right, you don't need to do this, but we've been focused on learning about precipitate and net ionic reactions. All right, we did the labs that support and practice these concepts. We started learning about acids and base reactions and about gas-forming reactions. That's what we did just today. All right, these are really very often tested. So the items that will be tested are net ionics, for sure, gas, and precipitate. All right, and then how to apply the solubility guidelines. Okay, we will learn oxidation reactions tomorrow, so remember to read 4.4. So the rest of the hour, what I want you to do is to work on these practice problems. So I'll have Heather go ahead and pass those out now. They're just on a half sheet, which is way too small for you to do everything on those. So use the half sheet just for the problems, but please fill them out on your own paper, which you will turn in tomorrow. So you have 20-something minutes, hopefully, to get that right now. And then anything you need for homework, or any time you need, the rest would be homework. So these cover anything from a precipitate, all right, to an acid base. And there will be some gas forming. So please practice these and just see how it goes. Make sure you pay attention to words like aqueous or gaseous or solid. All of these you should include the states, and you should be all right. So go ahead, work on those the rest of the hour, and thank you for your patience. And one more time, read section 4.4 tonight.